For this week, we're going to start to explore probability. This is something that you've been looking at every year in mathematics, and we're just going to continue on with what you already know. So one of the things that you've already always talked about are the terms related to probability. So thinking about an event and the likeliness of that event occurring. So for example, if I were to say, what is the probability of it snowing tomorrow? Now, in Canada, anything is possible. So it is possible that it could snow tomorrow, but it's highly unlikely. But I could ask a question around, will the sun come up? It's possible that it will not happen, but it's very likely that the sun will come up tomorrow. So there are terms, ways that you can describe probability: likely, unlikely, probable, improbable, very likely, highly likely. And these are things that you've been very familiar with. You've also probably had some experience representing probability with fractions, percents, and ratios. And we've worked with all of these things already. And so this should come back to you quite easily. All right, so I'm also going to talk about the theoretical, experimental, and complementary outcomes when it comes to probability. You've already experienced some of those in task number 1, and I'm just going to put the terminology in connection with what you've been playing around with. So let's go to that activity of flipping the coin. So if we think about the terms related to the outcome of me getting a head. So I flip a coin. How would I describe in words the possibility of me getting heads? It's very possible, right? If I want to do it in a fraction, I need to think about the total number of possible outcomes, and then, and that would be my denominator. And then my numerator is the number of times my desired outcome is possible. So let's look at the heads versus tails. So I have 2 possible outcomes. I flip a coin, I can only get heads or tails. So my denominator is 2. I have a total of 2 possible outcomes. Now, I'd like to get heads. So the numerator represents the number of times my desired outcome is possible. So of the total 2, my desired outcome is possible 1 time. Right? So representing the probability of getting a head when I flip a coin is represented by the fraction 1/2. Okay? So that's the theoretical, right? When I look at the math and I calculate, possible outcomes versus desired outcomes, that's the theoretical. That's the sort of math behind it. Now, the experimental is what actually happens when you do it. So if I were to flip a coin, 5 times, 10 times, 100 times, 1,000 times, according to theoretical probability, I should get heads 50% of the time. I should get tails 50% of the time. But that's not actually what happens when you do it, because there's other things that come into play. So the experimental probability is what actually happens when you test those outcomes. So one is sort of the math, and one is the actual probability of when you actually do it. Now, complementary, we hear this term in when we're talking about angles. We think about complementary angles and numbers that go together. And so that's kind of the same thing. So when we think about complementary probability, it has to do with, so this is the probability of getting heads. The complementary probability is the probability of getting tails. So in this situation, I have, half the time I should get heads. And if I look at tails, I have 2 possible outcomes, and my desired outcome is tails. It's 1 out of 2. So these 2 are complementary probability, and they should equal a whole, right? So if I have 1 out of 2 chances of getting heads and 1 out of 2 chances of getting tails, when I put those together, I would equal 1 whole. All right. So let's move on to percent, how I would represent it as a percent. So if I'm looking at heads versus tails, I know that half the time I should get heads, half the time I should get tails. That would represent 50%. I have 50% of the time to get my desired outcome of heads. And then ratio. Ratio is very similar to fractions. It's a ratio of desired outcome to total possible outcomes. So I would have my desired outcome is I have 1 chance of getting it to total outcomes, which is 2, right? All right, so let's look at the spinner here. So I've created a circle and a spinner, and I know they're not equal parts. I'm sorry, I hand drew it. but we're going to imagine it's been divided into 8 equal parts, okay? So the total possible outcomes is 8. And I want to talk about the probability of landing on purple, okay? So is it possible that I could land on purple? Of course it's possible. Is it likely that I would land on purple? Does purple represent a majority of the possible outcomes? No. There's 6 other colors, squares it could land on besides the purple. So it's not very likely. You could talk about being unlikely that I would land on purple. So that would be terms you would use to describe that spinner. Now we'll go to the fraction. So remember, for the fraction, the denominator is the total number of possible outcomes. So I know that I have 8 possible outcomes. So 8 becomes my denominator. And the numerator is the number of possibilities for my desired outcome. So I want to land on purple. So of the 8, I have 2 chances. I could lower that to the lowest fraction would be 1/4, would represent the same thing. But for this case, I'm going to talk about the total possible outcomes is 8, and the opportunities for my desired outcome is 2. So if I look at this as a percent, the entire spinner represents 100%. And so 2 of 8 would represent 25%. So I have a 25% chance, or the probability is 25% that I would land on purple. And again, going down to the ratio, it is possibility of my desired outcome to total possible outcomes, which would be 8. All right. So if we think about, I just want to go back to complementary. So when we look at the spinner, if I have the probability of me landing on purple is represented by 2/8. And so the complementary of that, landing on any other, would be 6/8. I have the probability 6/8 of landing on a different color, and then the ratio would be 6 to 8.